All right, my friends, it is the day, it is the time to talk about the quadratic formula, this formula right here. We're looking at solving quadratic equations, and we've looked at solving by factoring, but not all equations can be factored. So another method that we can use is called the quadratic formula. And it's basically just this formula you need to memorize. Our first step is going to look the same as it does for factoring. We need to get our equation in the form ax squared plus bx plus c equals 0, and then plug it into the formula. Something you might not be familiar with is this symbol right here. It has a plus sign and a minus sign, and the way we say that is plus or minus. Plus or minus. So that means we add or we subtract. You're going to do both because we're going to have two answers. We're going to do this one time where we add it and one time where we subtract it. So without further ado, let's do our first quadratic formula question. Step 1, again, we need to make it look like ax squared plus bx plus c equals 0, and you should be able to see, oh, it looks like that. Next, we're going to plug into the formula. So x equals negative b. And we are very familiar with finding a, b, and c. Right here, a is 4, b is 3, and c is negative 1. So we're going to do negative b, and I like to plug these in parentheses, especially if you have a negative number. Okay, so negative b, then we're going to use that symbol. Remember what I said that symbol is called? Plus or minus the square root. Then we're going to do b squared minus 4ac. What would we get if we plug in b squared minus 4ac? That would be 3 squared minus 4ac. 4a was 4 and c was negative 1. And then we're going to divide that by 2a. So what am I going to have on the bottom? 2 times 4. That's all you have to do. Then you just got to figure out what that equals. First thing we're going to do is simplify what's called the discriminant. The discriminant is what is under the square root, not including the square root. So first, simplify the discriminant. You could pull up the calculator and just type this into the calculator the way that it is, or you can figure out what you get just by simplifying it. 3 squared is going to be 9 minus 4 times negative 1. Next thing I'm going to do is multiply before I subtract. So exponents come first. What is 4 times negative 1? That's going to be negative 16. Okay, so 4 times negative 1 gives me this negative 16. Then I'm going to do 9 subtract negative 16. If I am at 9 on the vertical number line, subtracting negative would mean I move up. So what is 9 subtract negative 16? That is 25. 25 is what is going to be under the square root, and that is called the discriminant. Since the discriminant is positive, we're going to have two solutions, and since it's a perfect square, we're going to have rational roots. You'll see what I mean. I'm getting ahead of myself. Sorry. So we have negative b plus or minus the square root of 25 over 2 times 4. So again, the first thing I did was simplify the discriminant, and then this is the discriminant right here, and we got 25. Okay, next thing I'm going to do, just continue. I could do 2 times 4, which is 8. So I've got negative 3 plus or minus the square root of 25 over 8. And you're probably thinking, oh, well, the square root of 25, I know what that is. What's the square root of 25? That is 5. So we've got negative 3 plus or minus 5 over 8. Now, it says if the discriminant is a perfect square, is this a perfect square? Yes, that means we could take the square root of it and get a nice, pretty whole rational number. Then we just evaluate and simplify. We're on the lookout for two answers. We're going to have two answers from this. So I told you we're going to do one where we add and one where we subtract. We're going to do -3 plus 5 over 8. And then we're going to do one where we do -3 subtract 5 over 8. So that's what plus or minus means. That means we're going to add and subtract. And that will give us our two answers. So if I do -3 plus 5, if I start at -3 on the vertical number line, if I add 5, that's going to move me up to +2. And over here, if I'm at -3 and I subtract 5, that would move me down to -8. 2 over 8, that can be reduced to 1/4. And -8 over 8 can be reduced to -1. Those are our two answers. If we did that by factoring, we would also get those same answers. It's just a matter of having the formula memorized. Let's try some more. Okay, next let's look at this one's going to be a little bit different. And it says solve for all real solutions. We're using the quadratic formula here, so you've just got to have that formula memorized. Step 1. Make it look like ax squared plus bx plus c equals 0. And look at that, it already is in that form. Then I just need to say what a, b, and c are. A is 1, b is 5, and c is -4. We're just going to take those and plug them into our favorite formula. -b plus or minus the square root of b squared minus 4ac all over 2a. See if you can plug in those numbers. I'm going to plug in a b right here. B is 5. And then b squared right here minus 4ac. That would be 1 times -4. Whoops. Divided by 2a, 2 times 1. After you plug that in, the first thing we figure out is the discriminant. That's the number under the square root. Like I said, you could just type that into the calculator, 5 squared minus 4 times 1 times -4 if you want. Or you can figure out what it equals. So that would be 5 squared. Then we look at, we do the exponent first. Minus 4 times 1 times -4. Then we do multiplying before subtraction. So we're going to multiply these thingies together. What is 4 times 1 times -4? That's going to give me -16. So I've got 25 subtracting -16. So notice when I multiply this, I get -16, and then I'm bringing down this subtraction sign. If I subtract a negative, that is going to move up. So I would end up adding 25 plus 16, and that's going to give me 41. So again, if you just type this into the calculator the way it is, it would give you 41. 41 is the discriminant. Okay, so I'm going to put that into my formula. X equals -b plus or minus, and I got 41 there, all over 2 times 1, which is 2. So the first step I did, I went ahead and said what that was and what that was, but the first big step I did was calculate the discriminant. This is the discriminant, which is 41. If the discriminant is a perfect square, is 41 a perfect square? Definitely not. There's not a number that you can multiply by itself to get 41. So if it is a perfect square, we're going to get some pretty answers like we got last time. We got 1/4 and 4 or 8 or whatever. But this time, we're not going to get pretty answers. This time, we're going to get some irrational numbers. If it's not a perfect square, see if you can simplify the radical. This is why we spent some time on simplifying radicals before. If I try to simplify the square root of 41, let's see, what can I multiply to get 41? 41 is a prime number. There is nothing other than itself and 1 that you can multiply to get 41. So there's definitely no perfect squares that I could divide it by to simplify it. So what that means is I can't simplify the square root, and this says in simplest form. This is what in simplest form means. -5 plus or minus the square root of 41 over 2. So watch this, -5 plus or minus the square root of 41, and actually I do have to put the -5 up on top of the fraction, so I'm going to backspace that. All right, it says solve for all solutions in simplest form. I'm going to leave the answer like that, and it sort of looks like it's not finished. But the thing is that's an exact answer. And if we want to give them the exact answer, this is as exact as we can make it, because otherwise we're going to get an ugly number. So how many answers is this? This is actually 2 answers, like we're used to having 2 answers. We would find the 2 answers could be -5 plus whatever the square root of 41, it's an ugly number, divided by 2, and -5 minus the square root of 41 divided by 2. Those are our 2 answers, and you can actually just write it like this. That's how your answer is going to look. Even though it looks like it's not finished, those are the solutions. There's 2 solutions because there's a plus and minus. Let's do another example. This time it is not already in the form ax squared plus bx plus c equals 0, so we're going to need to get it into that form. And what I need to do is get 0 over here. In order to get 0 over here, I could add d to both sides, because I'm trying to get it to equal 0. Okay, this gives me 2d squared. I can only combine 5d and 1d. I can't combine d with anything else. So 6d minus 5. Then all we have to do is know our wonderful formula. We know that a is 2, b is 6, and c is -5. So let's plug it in. See if you could plug this into the formula. -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in for b, x equals -b plus or minus, and then we've got b squared minus 4ac all over 2a. First thing we're going to do is find what the discriminant equals. In this case, it would be 6 squared minus 4 times 2 times -5. That's going to be 36 minus, and let's figure out what this equals. 4 times 2. 4 times 2 is 8. 8 times -5 is -40. Okay, so I get 6 squared, subtract this. And if we are at 36, subtracting negative would move us up, and that's going to move us up to 76. 76 is the discriminant. Discriminant means number under the square root. All right, so let's plug that in. -6 plus or minus the square root of the discriminant all over 2a. Now, is the discriminant a perfect square? No, there is not a number that I can multiply by itself to get 76. So next we see if we can simplify the square root of 76. We talked about this a couple lessons ago, looking at simplifying the square root of 76. So in order to simplify the square root of 76, we want to look to see if there are any perfect squares that go into 76. So we can look in the calculator if you need to. I could see if 76 can be divided by, what are my perfect squares? 1 squared, 2 squared is 4. I can divide it by 4, sorry. 76 divided by 4 is 19. So, and then I know there's nothing that can go into 19. So that 76, the square root of 76 is going to break down into the square root of 4 times the square root of 19. All right, next thing I need to do is think about what the square root of 4 is, which is 2 square roots of 19. So what I'm going to do now is replace the square root of 76 with the 2 square root of 19, because that's the same thing, just simplified. So I simplified the radical, and I have x equals -b plus or minus. I simplified the square root of 76. So you're really going to do most of your work right here as your first step. All right, and then lastly, we do what's called the 3-number check. That's just what I call it. The 3-number check says that we're going to check this number, and this number to see if they can all be divided by the same number. This is like simplifying a fraction. 6, 2, and 4, can those all be divided by the same number? Yes, they can. And what is the largest number that they could be divided by? We could divide all of them by 2. Divide by 2, divide by 2, divide by 2. This is simplifying like you simplify a fraction. Then I get the answer, -3 plus or minus 1 times the square root of 19 over 2. And that is a simplified version. And if we're multiplying by 1 on a multiple choice test, that 1 would not be there. How many answers is this? This is 2 answers, and they're ugly numbers because our discriminant was not a perfect square. It's ugly numbers. But our 2 answers are -3 plus the square root of 19 over 2, and -3 subtract the square root of 19 over 2. Those are the 2 answers, and they're ugly numbers, so this is the exact answer where we don't have to worry about any rounding. So let's do one now where we leave it as a decimal. So we're going to, instead of leaving it like that, all that craziness, we're going to figure out what the decimal is. First step, make it look like ax squared plus bx plus c equals 0. Done. Easy. Got it. Next, we're going to plug everything into the formula. So all I really need to do is see what A, B, and C are and plug them into my formula. A is 1, B is -6, and C is -41. All right, let's write down what our formula is and plug in all of the values. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug in the b. X equals -b, which is -6. B is -6, plus or minus the square root of b squared, so -6 squared minus 4ac, -41, all over 2a. Next thing we do is figure out what the discriminant is, and in this case, this is my discriminant. Now you can type the discriminant into the calculator the way it is to have it figure out the discriminant for you. So if we go, you can pull up the Delta Math calculator and type in the discriminant. This tells me the discriminant is 200. Notice I didn't type in the square root. Okay, so this has a discriminant of 200. I'm going to bring down the rest. X equals, right here where I have -6, that is going to turn into a +6. Plus or minus, okay, and is this correct so far? No, I need to make sure you put the square root. We haven't evaluated the square root yet. The discriminant is just the number underneath the square root. Now, this says decimal answer. So if it didn't say decimal answer, we know that this is not a perfect square, so we would need to simplify that and then do the 3-number check. But this says decimal answer. So what we need to do is find the decimals. We're going to not give exact answers. So let's see what we get when we type in. I've got 6 plus or minus the square root of 200 over 2. So the first thing I'm going to type in is 6 plus, and then the square root of 200. Okay, that's going to be an ugly number. And then all over 2. However, I do need to make sure I put the 6 plus on the top and then divide that by 2. So let me backspace that. Okay, it says to the nearest tenth. So this tells me 10.07, if I round it to the nearest tenth, would round to 10.1. So if I do 10 plus the square root of 200 and divide it by 2, then one of my answers is 10.1. What would the other answer be? We could figure out by doing 6 minus the square root of 200 divided by 2. And the other answer is -4.1. -4.1. Okay, we're rounding to the nearest tenth. These aren't the exact answers because we had to round. If it asked you for the exact answer, we would simplify the square root of 200 and do the 3-number check and leave our answer more like this so that we have an exact answer instead of having to round it. Let's do another example. First step is to make the equation look like this, which it's close but doesn't quite look like that. What do I still need to do? I would add 17 to both sides to try to get it to equal 0. So now I have 4x squared minus 12x. And can I combine that 17 with anything? No, I can't. So I'm just going to do 4x squared minus 12x plus 17 equals 0. Next, we're going to figure out what A, B, and C are and plug them into our formula. Our formula is x equals -b plus or minus the discriminant, which is b squared minus 4ac, whoops, all over 2a. Let's plug that in. When I plug in the b value is negative 12. Negative 12. Okay, so b squared minus 4ac all over 2a, 2 times 4. Step 1, what do you do after you plug everything in? We find the discriminant, okay? You can plug the discriminant into the calculator just the way it is. And when we do that, I get negative 128 for the discriminant. The discriminant is negative 128. I'm going to bring down what the rest of it is. And while I do that, I am going to go ahead and multiply. Think about negative 1 times negative 12 would turn into positive 12. Plus or minus, don't forget that square root, all over 2a. All right, if the discriminant is a perfect square, is 128 a perfect square? Can I take the square root of 128 and get a whole number? No, I can't. And the thing that should stand out to you, this is the first one we've done, where the discriminant is negative. And we know how to handle that negative. What do we do to handle that negative? We just pull out an I. So make sure anytime there's a negative under a square root, you pull out an I. So this is going to be 12 plus or minus. I'm going to pull out an I since there is a negative under a square root. Okay? We just need to figure out what the square root of 128 reduces to. So I'm going to try to think of any perfect squares that go into 128. So I know my perfect squares. We know 1 squared, 2 squared. I'm just going to try some bigger numbers first. Like I know 36 is a perfect square, and that doesn't work. So let's try 128 divided by, let's see, we know 4 squared is 16. So 8 and 16, but I notice that 8 still has a perfect square within it. So that means I need to go higher than 16. Okay, if I do 64 times 2, that will work. So 128 breaks into the square root of 64 and the square root of 2. The square root of 64 is 8. So that would be 8 square root of 2. All right, so I'm going to replace the square root of 128 with 8 square roots of 2 because that's the same thing. Let's look at what I have now. 12 plus or minus. And watch what I'm going to do here. I'm going to do 8i times the square root of 2 because we want any numbers to come before I, but then we want the radical to come on the end, all over 8. So I took the square root of negative 128, and we know how to simplify it from our previous unit. And when I did that, I got 8i square root of 2. All right, next thing we need to do is the 3 number check since 128 was not a perfect square. The 3 number check means we check all 3 of these numbers to see if all 3 of them can be divided by the same number. So let's see if all 3 of those can be divided by the same number. Yes, they can. They can all be divided by 4, I believe, is the largest number. So 12 divided by 4, 8 divided by 4, and 8 divided by 4 is 2. All right, so let's see what we get. We get 3 plus or minus 2i square root of 2 all over 2. I reduce this, and these are my two imaginary answers. 3 plus 2i square root of 2 over 2. That's one of my imaginary answers. And 3 minus 2i square root of 2 all over 2 is the other imaginary answer. So basically, as long as you know this formula, all you have to do is plug in A, B, and C. Remember, get it in standard form first. And then what you do with your answers is going to be a little bit different based on what the directions say. Sometimes it's just going to be reducing, kind of like this here. If it says to round it, then it wants decimal answers. And if that's the case, you type into the calculator and see what the ugly decimals are. But keep in mind that you're going to have two answers. You're going to have two answers because of the plus or minus. Sometimes you might have, if the discriminant is a perfect square, you might have two pretty regular number answers. Okay, but always look at finding the discriminant first and then going from there.